Welcome to Engaging Saturdays with EM Educational Services. I'm Jennifer Bell, your host. Today we will be exploring the wonderful world of oceans. Most of Earth's surface is covered by ocean water. Millions of marine plants and animals call the oceans home. But oceans do much more than provide a habitat for animal life. Oceans have a big impact on human life as well. Our weather is heavily impacted by the planet's oceans. And get this, 70% of the oxygen we breathe is produced by oceans. What exactly is an ocean? Well, it's a large body of water, more specifically, salt water. We have 5 major oceans: the Pacific Ocean, the Atlantic Ocean, the Indian Ocean, Antarctic Ocean, and the Arctic Ocean. Where does all this water come from? Well, that brings us to our first activity, the water cycle. Grab your surprising science oceans kit and let's get started. The water cycle is the way water moves around our planet Earth. It's called a cycle because it's never ending. We have all the water that will ever be produced on our planet. No new water molecules are created. Instead, water changes form throughout the water cycle. Water from the ocean is heated by the sun. When this water evaporates or changes to a gas called water vapor, it travels up in the atmosphere. When water vapor collects with other water vapor molecules, they condense and form clouds. This is called condensation. Have you ever noticed water droplets accumulating on the plastic outside of your cup when you're drinking a liquid? That is another example of condensation. Clouds move across the sky as the weather changes. Once they become full of water, it drops the water back down to Earth in the form of precipitation: rain, snow, sleet, or hail. When the water falls back down to the ground, it collects in an ocean, river, or lake. Eventually, the water is heated by the sun again and evaporates, continuing the cycle. For this activity, you will need the following supplies: a quart-sized plastic bag, a small plastic cup filled with water, a permanent marker, and one of your blue coloring tablets. Now, let's start by setting the scene. On the top half of your plastic bag, let's draw some clouds and the sun. The clouds and the sun play an important role in the water cycle process. Do you remember what role each plays? Next, on the bottom half of your bag, let's draw some waves to represent the ocean. You can be creative if you like and add some ocean life into your ocean. Next, make sure you filled your plastic cup with water. Take your blue coloring tablet and place it in the water. Give it a few swirls and allow your coloring tablet to completely dissolve, tinting your water blue. Next, open your plastic bag and carefully place your plastic cup inside of the bag. Be careful not to spill any of your water. Once you have your cup of water inside of your plastic bag, place your plastic bag in an area that will get lots of sunlight, preferably next to a sunny window. Observe your plastic bag over the next few days and record your observations in your chart. Over 70% of Earth's surface is covered by water. Of that total, about 97% is ocean water. And remember, the ocean is very salty. In fact, humans cannot drink salt water until all the salt has been removed. That leaves only about 3% of water that is fresh water and can be consumed by humans and some other animals. However, most of Earth's fresh water, about 68%, is trapped in the form of ice and glaciers. And 1/3 of the remaining water is stored underground. So what do all these facts and figures mean? Well, it means that fresh water is an important resource and is limited in supply. Scientists all over the world are working on ways in which we can make sure there's enough water that is drinkable for future generations. In this next activity, we will be creating a model so you can see just how much water is available to us and why we need to protect this precious resource. Grab the following materials: 1 liter plastic bottle, which I have already filled with water, 1 small graduated cylinder, 5 small plastic cups, some salt, a permanent marker, plastic spoon, your petri dish and pipette, and finally 2 small blue coloring tablets. Fill your bottle with water and add your 2 coloring tablets to the water. Just gonna drop those in right there. I'm gonna close the top of my bottle and swirl my tablets around just a bit. Be careful not to spill the water. I'm gonna allow those tablets to dissolve. What do you think this represents in our model? If you said that it represents all of the water on planet Earth, you are correct. Next, take your permanent marker and label your plastic cups with each of the following: ice, groundwater, river, lakes. I'm going to label the bottle oceans, and my last cup I will label as swamps. Swamps, lakes, rivers, ice, which would include glaciers, and groundwater. Finally, oceans. Next, take your graduated cylinder and measure out water from your bottle into each cup using the measurements provided. For ice, we're going to measure out 20.6 milliliters of water. This represents the amount of water on Earth that is trapped in ice or glaciers. Next, let's measure out our groundwater. Groundwater represents 9 milliliters of our model. So measure out 9 milliliters of water. This represents the amount of water that is underground on planet Earth. Next, rivers. Rivers will represent 0.002 of a milliliter in our model, so roughly 1 drop of water. So I'm going to take my pipette and I'm going to place 1 drop. Oh, I did 2, but 1 drop of water will represent rivers. Next, swamps. Swamps will represent, in our model, will be represented by 1/100th of a milliliter of water, which would be roughly 5 drops. Next, we have lakes. Lakes will be represented by 8/100ths of a milliliter. Okay, there's our lake water. Now, the remainder of our water in our bottle represents ocean water. And remember, ocean water is not drinkable. So, what's included in ocean water that we haven't used in our model yet? Salt. So I want you to take 4 spoonfuls of salt and you're going to add it to your bottle. That's 1. Two, if you make a mess, don't worry about it. 3. And 4. Let's close that. I'm gonna shake that just a little. Now, look closely at your model. What are your thoughts? Ocean water that's not drinkable, water trapped in ice, groundwater, rivers, swamps, and lakes. Record your thoughts and observations on your chart. Did you know that the ocean has different layers? The top layer is called the surface. Below the surface is called the deep ocean, and below the deep ocean is a layer known as the seafloor sediments. The ocean is never still. In fact, it is in constant motion. If you've ever been to the beach, I'm pretty sure you've noticed the waves constantly crashing along the shore. This is because the ocean is constantly absorbing energy from the wind. Ocean waves occur at the surface layer when the wind moves across the surface of the water. As the wind travels across the water's surface, it pushes against it and the energy is absorbed by the water, which results in a wave. But let's put this into action and model an ocean wave. For this next activity, you will need the following materials. 1 liter plastic bottle with vegetable oil. I've already filled mine with water. And you will need 2 blue coloring tablets. Your plastic bottle should already contain vegetable oil. Fill the rest of your bottle with water. As you can see, I've added water to my plastic bottle. And you should notice that the oil has risen to the top, and the water that I added has now sunk to the bottom. I'm going to add my 2 blue coloring tablets and close my plastic bottle tightly. You should notice that your blue coloring tablets are mixing only with the water. They're not really mixing with the oil. Continue to observe and allow your blue coloring tablets to dissolve in the water. Place the bottle gently on its side and rock it slowly back and forth. You should notice that your oil never fully mixes with the water. Have you ever heard the phrase, oil and water don't mix? Well, this is exactly what our model is showing. The oil molecules are less dense than the water molecules, and so the oil rests on top of the surface of the water. This creates 2 separate layers. We have a layer of oil and we have a layer of water. The water is contained at the bottom, and the oil makes the movement of the water look like waves. Continue to play around with your model and record your observations. What do you notice about the way the waves of water are moving through the bottle? Record your observations on your chart. I hope you have enjoyed this edition of Engaging Saturdays with EM Educational Services. You have plenty more activities and experiments to conduct in your Surprising Science Oceans kit. Thank you, and see you next time.